Hello everyone and welcome back to another video, and today, as promised, I'm going to take a closer look at the GTX 1080 Ti AORUS PCB. Now, looking into this actually turned out to be better than what I expected. What I did expect is that this is basically a stretched 1080 Ti gaming OC. It is not. It is in fact better. So yeah, let's get right into it. So we're gonna start with the Vcore VRM, since that's generally the most interesting and important one. And it's controlled by this chip right here, which is a UP9511. This is an 8-phase controller, and the datasheet says it goes from 200 to 600 kilohertz. No, not kilohertz, switching frequency. And yeah, so first thing that you're gonna notice at that is that we have an 8-phase controller, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inductors. So yeah, we can't have a 12-phase on an 8-phase controller. So how do we get 12 phases? Well, we get them using these chips. And about these, so for a long time, me and other people have assumed that these are quadruplers. Turns out they are not. So if you hear me or maybe Bullzoid saying that these are quadruplers, it actually turns out that these are not. He later found out that these are actually dual doublers, and also told me about that. Because I don't actually have a datasheet for these, so I probably would have just repeated that here. But yeah, these are not quadruplers, these are dual doublers. So it's still one chip that spits out 4 PWM signals, but it takes in 2 and not 1 PWM signal, which makes this entire VRM a 6x2 phase. So 2 of the phases on the controller remain unused, and 6 of the phases, so I could just do it like this. That's how the PWM signals go. 2 PWM signals go into the dual doublers, and 4 come out. Kind of like that. Oh, did I miss one? Yeah, I messed this up. Anyway, like you get the idea, right? It's dual doublers. It's 2 doublers in one chip. It's not a quadrupler. It's 2 doublers in one chip. So yeah, and that then goes into our 6x2 or 12 phase. Like, doublers I think is a valid way of getting more phases. I'm gonna call this a 12 phase VRM. If you just shove 6 PWM signals into 12 power stages, that's still a 6 phase, but if you have doublers, then that's a proper 12 phase in my opinion. So this is going into this 12 phase Vcore VRM, which has these components for its power switching component, and these are AOZ 5036s, and these are 60 amp DRMOSs, or up to 60 amp DRMOSs. You're never actually gonna run 60 amps through these, but you know, they technically go to 60 amps, which is better than the 50 amps that I was expecting. I thought this was using FDMF 6823Cs, just like the 1080 Ti Gaming OC and a whole bunch of other cards that exist. But, you know, this is using 60 amp DRMOSs, which probably means these are slightly more efficient than the 50 amp ones, and like they can handle a bit more current in the same operating conditions as the 50 amp ones. But mostly the higher rating should just mean that these are probably a bit more efficient and run a bit colder because of that, and so the VRM gets a bit stronger. In fact, 12 times 60 amps is the exact same rating that the 980 Ti Strix has, for example, or the EVGA ePower 5. All of these have 12-phase Vcore VRMs with 60 amp components. Now those two use IR Power IR stages, IR 3550s or 3555s, if I remember correctly, which is not the same as this. This is what they call this is called a DRMOS by the datasheet. The other thing is an actual smart power stage. That one has a bit more fancy features, but as for the actual power switching component, these is probably like very similar. I don't really do efficiency calculations like Bullseye does in his videos. I don't know if he still does PCB breakdowns of his. I haven't seen one in a while. But if he still does it, he's gonna have good data. I don't think he does all the cards like this anymore, but whatever. I don't do efficiency calculations because I don't know how, and if I did, I'm not sure if I was willing to put in the time. But anyway, yeah, so this Vcore VRM is probably more than you're ever gonna need, because this is the same sort of total current rating that you get on a really good 980 Ti, and 1080 Ti versus 980 Ti in power consumption is very different. Like 1080 Ti is nowhere near the same amount of power. I think even on LN2 these max out at like around 700 watts with maybe peak at 1000 watts. That's like nothing for a 980 Ti. A 980 Ti on the LN2 can max out in ePower 5, which is this same VRM basically. Which like 980 Ti on LN2, you actually need like a Galax Hall of Fame power board for that, which is like basically this VRM but like 16 phases instead of 12. So yeah, like for 1080 Ti, this VRM is just fine. Like this is just fine. This is probably up there. I don't specifically remember what the Hall of Fame and the Kingpin have. This should be better than the Strix, because I think the Strix is just an 8 phase on 60 amp DR or maybe power stages. But like this is probably not quite as good as the Hall of Fame or Kingpin, but like it's one of the best VRMs for 1080 Ti's in my opinion. So Vcore VRM, power-wise, completely fine. Filtering-wise, this card has a bit of a unique approach, but that might change depending on which version of this card you have. Now I have the AORUS. There's also the AORUS Extreme. And I have heard from some people that the AORUS Extreme will maybe populate these empty pads for multi-layer ceramics on the front and back of the card, which should give the Extreme a slightly better output filter. But I can't confirm nor deny that, so I'm just gonna see what it, like, I'm just gonna talk about the stuff I have in front of me, which is the regular AORUS variant. And the regular AORUS variant has a buttload of these 330 microfarad SMD polymer capacitors. Like it has these on the front, it has more of them on the back, and that's basically the entire bulk output filter. There's no can types, there's no multi-layer ceramics. There's a bit of a fancy thing going on behind the core, but we'll talk about that later. But as for the output filter, it's only 330 microfarad SMD polymers, which is a bit unusual. You generally want different types of capacitors in your output filter to like have the kind of best transient response, but you can also just like put a lot of the really good capacitors. It's just gonna be a bit more expensive. Like I'm saying, this is probably fine. It's just a bit unusual because usually you see some multi-layer ceramics or like some can types if you just want a lot of capacitance for relatively cheap. This card goes with a lot of SMD polymer capacitors, which are better than can types. And they're sort of like a good middle between can types and multi-layer ceramics, because multi-layer ceramics are really good at filtering. They don't have a lot of capacitance. And can types have a lot of capacitance, but are not really good at filtering. And then SMD polymers is kind of like in the middle, where they're like better than can types at filtering, but worse than multi-layer ceramics, but like have a lot more capacitance than them, but not quite as much as can types. So if you're gonna set out to only use one capacitor type, this is basically what I would choose. And it's not like the card doesn't have a lot of capacitance. It has like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then that's probably another 12 on the back. Yes, it is. So it has 2 capacitors per phase. That should be enough. Like, that should be enough. So even though the output filter looks a bit this is probably fine. And the input filter is, yeah, that's enough. That will be enough. There's more input filter over here. That's also input filtering, but for memory. That's output filtering for memory. But yeah, input filtering wise, like, it's pretty hard to find a high-end NVIDIA card or at least a custom high-end NVIDIA card that doesn't have enough input filtering. Like having low input filtering or like not enough input filtering is kind of a recent AMD high-end card problem. And it looks like the 7900 XTX is gonna have the same problem again, because they showed some renders of the PCB and it basically has the exact same input filter that the 6900 XT has, which was not enough. And the 7900 XT uses more power, so yeah. But input-wise, this is fine. Like that, this is fine. Then for the, let's clean this up a bit. For the memory VRM, let's just clean all of this first. Yeah, so for the memory VRM, we have, actually I'm not too sure which controller it is. It might be this. It might be something else. That's the INA3221. That's for the power monitoring. We'll go into shunt mods and power mods later. So for now, I'm just going to assume that this is like some random two-phase controller. Like Richtech is used a lot for NVIDIA cards, at least in the past. Maybe this is like a two-phase Richtech controller. I don't know which one it is. Like the only datasheet I have for this card is the UP9511 and the AORUS. But yeah, like the memory VRM is a two-phase, and it's using two dual NFETs. Probably the same dual NFETs that they were using on the gaming OC and also the 980 Ti gaming cards. And on the 980 Ti, this VRM kind of had a tendency to blow up, because on the 980 Ti they only used one dual NFET per phase. You can see that they've learned from their tendency to blow up, because they are now using two for each phase. Though I think I've seen at least one card that still blew up. And I have to admit, the cooling for this VRM is not the best, because there is a thermal pad for the inductors, there is a thermal pad for these two capacitors, and that's it. There's no thermal pad actually contacting the MOSFETs. In stock configuration at least, I did add like a thicker thermal pad below the capacitor thermal pad so that the MOSFETs are actually getting heat sinked, and I also put some behind the back plate. But yeah, you might want to put a thermal pad on the MOSFETs if you have this card and are a bit worried that this might blow up. I don't think it will, but like it can't hurt to put in a bit more thermal pad there. But yeah, so like this is a two-phase, just standard memory VRM, two dual NFETs. I don't actually know if this pulls more power than regular GDDR5. It's one chip less than the 980 Ti had, but this is GDDR5X, which might draw more power than regular GDDR5. I'm not entirely sure. So I can't really say how adequate this memory VRM is, but I also haven't really seen any super fancy memory VRMs on 1080 Ti's. Like 2080 Ti's is like where the memory VRM kind of became a lot more powerful, because a lot of those have 3 phases, and then the 30 series went to 4 phases. But yeah, so like about the memory VRM, this is probably fine-ish. Like, I can't really say that much. I can say that the output filter is, there's not that much bulk filtering. There's like nothing. There's like these 4 multi-layer ceramics on the back and then nothing. There's just a whole lot of empty, like these 2 empty output filter pads and then a lot of empty input filtering pads, because, you know, needs more input filtering, already has way too much. So the output filter, the bulk output filter is kind of meh. But then again, this is a card that has the memory VRM like very far away from the memory chips, which has some unique challenges with it, because you're gonna have a lot of voltage drop going from here to there, especially if this entire Vcore VRM is in the way. And so it doesn't mean that you can't do this, but it means that your output filter looks a bit different than you would kind of expect it to. Like EVGA has been doing this in a lot of their classified cards. And Gigabyte is doing a similar thing here, because you can see that here's another output filter capacitor. Here's 2 other output filter capacitors. These are memory, not core. Here's another one. Here's one. And then it just gets like progressively more capacitance behind the memory chips as you go farther away from the core. And my tablet just, why does it always do this? Why does it do this? Yeah, so there is a lot more capacitance very close to the memory chips and not at the VRM. Now there is these two capacitors at the VRM, so you have a little bit of bulk capacitance. But there is this higher number close to the chips. So if your memory VRM is far away from the memory chips, what you kind of do is just kind of like put your output filter, like your bulk output filter, closer to the memory chips, and then just kind of have a higher output voltage on the memory VRM. Because then that way you drop the voltage by the time you get to the memory chips, and then you have your output filter there, which is the same thing that EVGA did on their classified cards, and it's also what Gigabyte does here. And it seems to be working quite well for them, especially this part, where there's like basically a capacitor for every chip that they put on the board. Because this thing is really good at memory overclocking. Now it might just be that I got lucky, but this thing, stock, no mods, maxes out the memory slider at plus 1000. And like that's like 1625 effect, like DRAM clock, which I've been told 1080 Ti's start at 1400 and end at 1650. And for 1650 you need like a modded BIOS because the slider ends at 1625. So yeah, this thing is really, really good at memory overclocking. Might just be random chance, but I have a feeling that it has something to do with like the massive capacitors that they put very close to the memory chips. So yeah. Then, yeah, let's talk about the stuff behind the core and then we'll go into power mods. So I said before that there's some funny stuff going on behind the core. And it's kind of a similar thing to what Gigabyte has done before. And that is that they put 560 microfarad SMD polymers behind the core. And actually they also slightly changed the layout. As far as I know, regular 1080 Ti's don't have 4 of them behind the core. I think they have 2, and then more multi-layer ceramics instead of the other 2. So what Gigabyte has done here is upgrade the capacitance of the SMD polymers and replace some multi-layer ceramics with SMD polymers. Now this has potential negative implications because multi-layer ceramics are better at filtering, and you generally want multi-layer ceramics behind your core because they have like the very high frequency stuff going on. But you can also have a benefit by just having more capacitance. And 560 microfarad is more than you can ever get with multi-layer ceramics. The highest capacitance rating that you can get multi-layer ceramics in is 47 microfarads, and in the space of one SMD polymer, you can fit 10 multi-layer ceramics for an effective capacity of 470 microfarads. But these are 560s. So by doing this, you get more capacitance directly behind the core, but that capacitance is slightly worse at actually filtering. So I can't really tell if that's a net positive or net negative. I have had quite a lot of cards from Gigabyte that do this. I've had a 980 Ti Gaming Extreme from them before I sent that off. That one did really well on the core. This one, which does okay for the core, it's not bad, it's not great either. And then my 2080 Ti, which also has this behind the core, and is also like not bad, but not great. So I haven't had the card with this yet that did bad on the core. I've had one that did really, really well, and then 2 that just kind of did like slightly above average, I guess. So I haven't had yet an example for this being bad, but I've only had really one example where like the card did really well. So worst case, I think this does nothing, and best case, this gives you a slight advantage for overclocking, just kind of based off the experience that I had. One thing that they actually didn't include on this card is that you can see the card has at least 3, this one's kind of not there, of the extra mounting holes, which on the 980 Ti And the 2080 Ti that I have, Gigabyte actually filled in with the missing multi-layer ceramics that they evicted from the backside of the core. That is probably really helpful on the other cards. Like, it's just more capacitance in addition to like that maybe slight increase in overclocking potential behind the core. On this card, they didn't include that for some reason. Now the hole on the bottom isn't there because this chip sits here, which I think these two are switches used for enabling or disabling that HDMI port, and then also that HDMI port can also be toggled, and like the card is like this display switching thing, which Gigabyte has done on the 900 and the 20 series too. And as far as I know, these switches are responsible for doing that. And also the card is dual BIOS because of that, because this display switching thing is done by just switching to a different BIOS chip as far as I know, which is why you have to reboot the card when you want to switch display outs, because the card only loads the BIOS at boot up. But yeah, as far as I know, in order for all the outputs to work properly, the BIOS has to, have it programmed into it, which outputs are connected to the card, and there's a maximum amount of outputs that the card can have. So if you want more than that, you need two BIOS chips, which are then responsible for some of the outputs, and then another BIOS chip that's responsible for the others, but you can only use one at a time. So yeah. So this dual BIOS doesn't really have a dual BIOS switch, but you can like kind of force the card to switch between BIOS chips by just plugging in different ports on the card, which I mean is better than not having dual BIOS. But like this is it's more like dual BIOS because of the display switching feature and not just plain dual BIOS. But yeah, so there's that part. Yeah, back to the backside of the core, like, it probably doesn't hurt anything based on my experience. It might also not really help that much. It's just kind of interesting that Gigabyte does this. I think the only other manufacturer that ever tried this was Zotac on like a very limited amount of cards only. But Gigabyte has been doing this quite consistently for like the 900 to 20 series. I'm not sure if they did it on 30 series. And I think on 700 series they didn't do it yet. That might be wrong though. They might have done it on 700 too. But yeah. So now for the last part, which is power mods. So 10 series is a bit special because 10 series has you can't make custom BIOSes for it. So my usual way of removing power limits on NVIDIA cards is just to make a custom BIOS that has a 999 watt limit. But that doesn't work anymore on 10 series because you can't make a custom BIOS for it. Another thing that works on 600 to 900 series cards is to just take this INA 3221 chip right here and just remove it. That gets rid of the power reading and therefore the power limit on 600 to 900 series cards. But on 10 series cards, this doesn't work either, because I've been told if you try to remove this chip, the card will still work, but it won't go into 3D mode anymore. It will effectively be in safe mode and not boost to 3D clocks because of that missing power reading. So there's a sort of failsafe in the 10 series cards for when the INA 3221 stops working. Which means the only way to remove the power limit on the card is to actually shunt mod. And we have all our shunts in this sort of area. We have one here, another one here, and the third one here. So these two up here for the 8 pins are 2 milliohms. And this one down here is a 5 milliohm. So the 5 milliohm one is PCI Express slot. You might want to leave this unmodified if you don't know what you're doing. Like if you have a motherboard that has an extra supplementary power connector, you can probably do this. Or like generally you should kind of be able to do it if you have no other PCI Express devices, because the PCI Express slot is rated for 75 watts. And you can have like up to 4 PCI Express slots with stuff in them that pull 75 watts. So theoretically, if you have only one card in the system, you can 4 times the PCI Express slot power before you hit like the actual design limit of the motherboard. So Like, you should be able to get away with it, but I don't really want to give a go ahead here and then have someone break their board. So if you're not sure that you can take it, just don't modify the 5 milliohm one. But yeah, but you can modify the 2 milliohm shunts, which are just for the 8 pins. Like, the 8 pins are rated for 150 watts each, and you can easily at least double that without issue. You can probably do a lot more than that. Yeah, since these are 2 milliohm shunts and not 5 milliohm shunts as most are, you can use lower resistance shunts to mod this. Based on my experience with the 1060, you should probably be able to put more 2 milliohm shunts on this to effectively have 1 milliohm, which doubles the power limit on the 8 pins. I've been told that if you just put the same value on top, you sometimes get stuck in safe mode, but my 1060 didn't. I was able to put 5 milliohms on 5 milliohms and just half the resistance. So you could try 2 milliohms on this. If that doesn't work, try like a 3 or 4 milliohm, maybe a 5. Like, the higher resistance shunt resistor you put on top, the less your power limit will expand by. But based on my 1060 experience, just putting 2 milliohm shunts on top of these should be fine. And yeah, that's basically it. Is there anything I've missed? I don't think so. So yeah, that's the GTX 1080 Ti AORUS. Not a very common card, or at least in Extreme Overclocking, very common card. Like, I see a lot of Strixes and of course Kingpins and Hall of Fames, but this is not too bad. Like, it has dual BIOS. You kind of need to do weird things to activate it, but it has dual BIOS. It has a Vcore VRM, which is, from what I can tell, stronger than the one on the Strix, and probably pretty close to whatever the Kingpin and the Hall of Fame have. Like, the filtering looks good. It could be better, but for 1080 Ti, since like they have rather low power draw, like the 1080 Ti is a kind of an anomaly with how little power it actually pulls. Now, that doesn't mean that it can't do 700 watts. It will do 700 watts, but like the other cards would do it in excess of 1 kilowatt. So, yeah. Yeah, like overall I like the card. Like, mine does really well for memory overclocking, which might be due to the extra capacitance behind the memory, like I said. Vcore VRM is strong enough for everything you should be able to throw at this. Yeah, like I like the PCB. It looks like a pretty good, capable 1080 Ti PCB. It's not specifically designed for extreme overclocking, but you can make it work. And with that, I would like to end the video. So thank you for watching. Hope you enjoyed, hope you learned something, hope you found it interesting. And until next time, goodbye.